Hello everyone. So today we are going to discuss about transmission media in computer networks. So you know how importance of transmission media in computer networks. So basically, uh, a physical layer will be in touch with the communication media. Right? So there are basically two types of communication or transmission media. One is guided or wired transmission media. The second one is unguided or wireless media, right? Further, uh, both guided and unguided media are divided into a number of types. We'll discuss a few types of guided and unguided media in this video, right? So let's get started. So, so guided media means, as the name suggests, guided media is the transmission. It's a type of transmission media that has a dedicated path between the sender and receiver. So, if you have a dedicated path between the sender and receiver, then it will be categorized as guided media, right? Same like cable, right? Um, Electrical cable connecting the switch and light or switch and fan, right? So there is a dedicated medium to transmit the current or voltage from the switchboard to the electrical appliances, right? So it is defined as the physical medium or physical media through which the signals are transmitted. So the loss of signal is very pretty much low when compared to unguided media, right? So the some well-known types of guided media are twisted pair cable, coaxial cable, and fiber optic cable. So we'll discuss about twisted pair cable first. So twisted pair cable, again, as the name tells you the meaning of the cable, right? The cables are twisted intentionally with each other. There are pair of cable, right? Both cables are twisted with each other purposefully at an angle, right? So it is twisted because to reduce the loss of the signal, electrical loss of the signals, right? So uh, even in your homes, you can see uh, most of the electrical uh, cables are twisted, right? So the frequency range of the twisted pair cable is from 0 to 3.5 kilohertz, right? 3.5 kilohertz. So the number of turns the twist, right, will determine the noise interference, right? Right, will reduce the noise interferences. So there are two types of twisted pair cables. One is unshielded twisted pair, shielded twisted pair. So the simple difference is, see, if you look at the diagram, uh, there is a metal shield to protect the pair of cables, right? Whereas in unshielded twisted pair, there is no such metal shield. That is the only difference between unshielded twisted pair and shielded twisted pair. And application wise, there are some differences. See, unshielded twisted pair cables will be used mostly in telephone lines that have low speed data, and it can support variable data range, right? So category 1 is used for, I have prepared this table only for understanding. Category 1 unshielded twisted pair cable is used for telephone lines, and category 2 is used for telephone lines, but it supports data rate up to 4 megabits per second. Likewise, we have category 3, 4, and 5, depending upon the data rate that it supports, right? So the advantages of unshielded twisted pair or UTP is it's pretty much cheap compared to the shielded twisted pair, right? Installation of unshielded twisted pair is very easy, right? And it can be used for high-speed LAN also. By using category 5 or category 4, we can implement high-speed local area networks, right? And the disadvantage is this cable can be used only for short range communications because of attenuation, high attenuation. There is no protecting metal shield like sealed twisted pair cable, right? Whereas sealed twisted pair cable slightly costlier than unshielded twisted pair, and it is but it is not very much high compared to optical fiber or coaxial cable. Again, the installation of sealed twisted pair is also easy, right? It has high capacity compared to unshielded twisted pair, right? Attenuation is slightly better than uh, unshielded, but again it has higher attenuation when compared to coaxial cable or fiber optic cable, right? So it is expensive than UTP, and it has also a high attenuation rate, right? So the second key type of guided media is coaxial cable, right? Coaxial cable um, is mostly used for cable transmission, right? Or uh, DTH, right? Direct to home, your direct to home uh, applications, right? Are mostly using coaxial cables, right? Coaxial cables. So it consists of two conductors, right? One is inner conductor, another one is outer conductor, and both will be separated by a insulator, right? So there are two conductors, inner conductor and outer conductor, and everything will be encapsulated in a plastic cover, right? Plastic cover, and it will be uh, the insulator will be used to uh, protect the signal attenuation, right? The middle core is responsible for data transfer, right? So if any signal is trying to escape from the inner conductor, the insulator will prevent it from escape, right? So the coaxial cable is of two types. It supports both baseband transmission and broadband transmission. So baseband is uh, uh, the process of transmitting a single signal, right? Single signal at high speed, whereas broadband signal, multiple signals, right? Multiple signals simultaneously, right? But the application wise, coaxial cable is mostly used for TV transmissions, right? Cable transmission or TTH signal transmissions, right? So the advantage is it can be used for high speed transmissions, right? It has better shielding when compared to twisted pair cables, and it provides higher bandwidth. Disadvantage is more expensive compared to twisted pair cable, right? When fault occurs, it will cause the entire network to fail, right? So the third type of guided media cable is fiber optic cable. Fiber optic cable uses light signals, whereas the previous two cables, uh, coaxial cable and twisted pair cable, uses electrical signals, right? Electrical signals, whereas fiber optic cables uses light signals for communication, right? So we have to generate the light uh, signals to transmit data from sender to receiver. And um, there are again three layers in the optical fibers, right? So optical fibers is pretty much costly compared to the previous two types of cables. The plastic coating protects the optical fibers from heat, cold, and electromagnetic interferences, right? So it consists of two surfaces or two layers, core and cladding, and the outer uh, layer will be protected by the plastic coating, right? So this is the side cut and slicing view of optical fiber cables. See, uh, it consists of two layers, core and cladding. The core and cladding will be encapsulated in the plastic jacket. This is the uh, slice view of or end view of optical fiber cables, right? And it supports variable transmission modes like single mode, multi mode, right? Step index, grad index. So the core and cladding will be either made up of glass or plastic, glass or plastic. But the protective jacket is only made up of plastic, right? The only purpose of plastic jacket is to preserve the fiber strength and absorb shock and extra fiber protection, right? Whereas core and cladding will be either made up of glass or plastic, right? So as we discussed, it will support a single mode and multi-mode transmission. See, on the right hand side, single mode, uh, it will pass the signal uh, only in the one path. You can say easily, right? Signal will be transmitted in only one direction, right, or one path. Whereas in multi-mode graded index or step index, right, the signal will be traversed in multiple directions or multiple paths, right? So when you are transmitting signal from the source to destination, the signal will be traversed in multiple directions or multiple paths. Right? The paths will be determined by the angle of incidence. Right? Angle of incidence is nothing but, so see, example, you have generated a light signal, right? Uh, you have to uh, join the light signal from the source, LED source, to the cable. So while you are uh, connecting the light signal from the source to the cable, right? The the angle at which the light signal interprets with the cable is called critical angle, right? The angle of incidence or critical angle. So the if the critical angle is equal to the uh, refraction angle of the fiber optic cable, then it will refract like this. It will refract 90 degree, exactly 90 degree to the angle of axis of the cable, right? If the critical angle of incidence is less than the critical angle, then the refraction will be pretty much less, right? And it will be almost equal to the axis of the cable. If the critical angle is greater than the incident angle, right, the refraction is quite opposite, 180 degree almost, right? So like so it depends upon the angle of incidence and critical angle, the refraction will take place in fiber optic and it will determine the uh, path direction, right? So the advantages and disadvantages of optical fiber cable. See, increased capacity and bandwidth. So it will support large bandwidth transmission, lightweight, because we are using glass or plastic as the core and cladding layers, and outer jacket, right, will be made up of plastic, right? And attenuation is very less, right? Immunity to electromagnetic interference is also very less. Sorry, electromagnetic interference is very less, right? And it will provide resistance to corrosive materials. But the disadvantages is it requires skilled laborers to install and maintain the cable and high cost and it is easy to fragile, right? And you cannot easily bend the cable while installing the cables, right, for long transmissions. And unguided media transport. So the second type of media is unguided media, right, or wireless media. So there is no dedicated path between the sender and receiver, right? So we are using the AR as the medium, communication medium, right? AR as the communication medium, and the unguided media will be categorized into different types like radio waves, microwaves, infrared, low frequency, high frequency, right? So for your understanding, I have prepared this table. See, low frequency, high frequency, medium frequency, very low, high, low. So the frequency range and application, right? So if the frequency is range very low, low means 3 to 30 kilohertz, right? Low frequency means 30 to 300 kilohertz. And low frequencies and very low frequencies are used for ground level propagations, right? Ground level propagations. The application wise it will be used for long range radio navigation, radio beacons and navigation locators for GPS, right? Whereas medium frequency or high frequency levels are used for high level propagations, AM radios, right? Sedition band for SIP aircraft communications. Whereas very high frequency, ultra high frequencies are used for TV, FM radios, and it requires line of sight, right? Uh, Very high frequency will be propagated in the sky mode or line of sight mode. Extreme high frequencies, super high frequencies are used only for line of sight applications like satellite, radar, right? So the overall frequency range is varies from 3 kilohertz to 300 gigahertz. So the frequencies are divided into various categories, right? And here is the comparison about various unguided media, radio waves, microwaves, infrared waves, right? So radio waves, there is no direction race required for radio waves. It's omnidirectional. So you can transmit signal in 360 degree and you can also receive the signals in all the directions. Whereas microwave and infrared waves are unidirectional in nature. So one direction, right? It requires line of sight, right? And they can use low frequency so that they can penetrate through objects, walls, trees, right? Whether it is moving object or a non-moving object, it can penetrate. Whereas microwave, infrared waves cannot penetrate, and the frequency range is from 3 kilohertz to 1 gigahertz for radio waves. Whereas microwave frequency range is from 1 gigahertz to 300 gigahertz. Infrared wave ultra high frequency, right? So 300 gigahertz to 400 gigahertz. And whereas radio waves doesn't provide any security, whereas microwave provides little bit of security. Infrared wave high security. Attenuation is also high in radio waves, whereas microwave and infrared waves low, right? So usage cost is also moderate, whereas microwave and infrared wave is costly, right? So radio waves is used in long range communications. Microwave is used in long distance, but infrared wave can be used only in short range and long range communication. So this is the overview about different types of cables, right? Uh, so if you have any queries in this video, please you can post it in the comments. Thank you, guys. Thank you.